Yo, yo, I think we're live. How's it going, Debatron? Gonna make a quick coffee, wait for some people to join, and we'll get at her. Turn that off for now. So after that video, started going over some graphics cards. This is the GTX 770 from EVGA, same thing. Because I wanted to see if I had spare parts. This card here, rest in peace, was doing some mods on it, and Gabby jumped on my lap, and it kind of fell over when I was doing a mod. It ripped off a whole bunch of stuff, unfortunately. But that's in the past. But I was looking at it, I'm like, those MOSFETs look similar. I wonder if they're the same as my GTX 460 here. Wow, what do you know? They're the exact same. For the high side and the low side MOSFETs on this one here, it's the exact same for the GTX 460. So I am amazed on that. Yo, how's it going there, Sync? Yeah, I'm shocked. So this card here, it only has one blown MOSFET onto it because I tried to fix it up. I was hoping I could figure out the traces. It's very hard to see on this. Don't mind the cat hair, it's been sitting for a while. I was trying to figure out the traces for here because when it fell over, it ripped off a bunch of components and ripped the traces completely out of it. So what I wanted to do, and probably will do later on, is try to buy some broken GTX 770s and replace this whole chip. So this is like resistor divider. All these little resistors and caps go to this chip here, and then everything gets soldered to this chip gets soldered to the board. So just replace it basically, and I'll do that when I get some broken GTX 770s and redo the mod. And what I want to do as well is add on some more, just completely modify this card later on. But for now, I can take one of the MOSFETs because somehow they're the exact same. I did some resistant testing onto them. So I was just doing resistant testing because it's very hard to read these MOSFETs because I haven't set them up to be able to read them. Use a little bit of thermal paste. You put a little, I'll show you here in a second. But I was checking them for the resistance on the 3 pins. So ground, 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 gate. So that's our power. See how we have high resistance? And then if we go over to here, these are the same MOSFETs over there, so I'll just go off the memory chips here. I'll go on to the 4th pin over like I did over there. High resistance. So these I already set these all up so I can read them. That's why you can actually easily read them. If I zoom in, see how you can see, focus you. See how you can actually read them. 4935N. These ones you can't really read due to the fact they're not set up yet, and I will show you here in a second with some thermal paste. But if you look close enough, like put your eyeball close enough, you can read 4353 N as well, which is the exact same MOSFETs, and the high side and the low side are the exact same. So I'll just take one of the low sides, since I'm missing a low side, and replace that from this donor board that again we'll be fixing up later on. But yeah, and probably we'll add in another 8 pin to this card later on, because it will be pulling a lot of watts. Especially when I get it all chilled and modified, I'll probably be pulling like 700-800 watts just the one card. But yeah, I'm very shocked. So I was like, you know what? I'll do a live stream of showing how I'm going to fix this up. And if anyone wants me to show them how to check over cards to see what's wrong and right, you know, shorts and faults and stuff like that, I can do that. Plus, I have to add on a bunch of capacitors still, because I took off a bunch of caps, MLCC caps, aluminum polymer caps as well, which are just the can style caps. I'm replacing a bunch of caps too that were just 10 microfarad caps to 22 microfarad caps as well, and maybe that will help a bit for the overclocking. But this card's been heavy modified. Everything you can think of has been done to this card already. Like literally every modification you can do basically to a graphics card. And I'm just making myself a quick coffee. I need more sugar. Because I want to get this card running up appropriately. So that way, when I put it into the trash cup for my 2010 build, every component can be from 2010. PSU, GPU, CPU, motherboard, RAM, everything, and even the computer case will be all from 2010. So I want to get it up and running perfectly and get that going. How's it going there, Squeeze? Tweezers. What do you mean it's strange? What do you mean? What do you mean? Are you sure? Wait, 7850. It should be around 1050. I don't think. Well, no. On some cases, the 7850 will outbeat a 1050 Ti. In some cases. In some cases, it will. So maybe not for gaming for certain games, but it does from what I remember. You know, my memory, it's pretty good. I don't think you're gonna get close to the 1060 world record. Well, a bunch of the scores. What 3D Mark though? 3D Mark is is Steel Nomad, is Fire Strike, Time Spy. There's so many benchmarks on 3D. But 3D Mark is just a is just a benchmarking site. It's not a benchmark itself. Ooh, sweet, sweet coffee. I want my sweet, sweet coffee. Nice. Oh yeah. That's so good. That's quite of an improvement. Doesn't really seem right to my opinion. That does not seem right. Okay, so first what I'm gonna do is grab this card. Move that card out of the way for now. We don't need the multimeter. Sorry for the bang there. Don't need the multimeter right now. So what we're gonna do, I'm gonna zoom in for you. Grab a little bit of flux. Just a little dabby dab. A little bit of flux. Just gotta clean up my soldering tip. Clean it up real good. Get ready for this. Oh, where's my... I need my shoulder. I need my shoulder. Shoulder. Where's my shoulder? I got a new thing of solder here anyway. Well, not new by any means, but I got a pound of solder. I got a pound of solder here. We can use that. Just want a little bit. A very little amount. And we're going to clean up this pad. And these little guys over here. We're just going to hit them with some new solder. Make sure we hit that real good. And we're going to warm up the board a bit. No need to go nuts with it. Put it down to about 500 Fahrenheit. Nah, let's go 400 for now. 400 Fahrenheit will work. Yeah, there we go. That's better. I'm just gonna pre-warm up this board here. And then I'm gonna what I'm gonna do, yeah, let's hit it with soldering iron again here. There we go. That's better. Oh my goodness, that's good. That's a beautiful. Oh my goodness. And we're gonna clean up this flux off of there with our Q-tip. And we're gonna clean up where I did it beforehand too. As you can see, nice and shiny. You'll have a little blob there. I would like to get rid of that little blob. I would. So, clean up the tip again, get rid of any solder off the tip. And when we hit this again, like so, we'll start pulling some of this blob away. And then I'll grab a little bit more flux, hit it again in a second here. There we go. Just a little bit of flux. And that little bit on there is fine with me. Make sure this is all nice and cleaned up. Nice. Now this is prepped. Prepped good enough for what I need to do. It's not like I'm going to hit it with any wicking at all. I'm not going to wick it at all, redo it with new solder. What I basically did was just add in solder. This is not the greatest solder. This is a 50-50. A 6733 it's a little bit better, or a 60-40 would be better, but a 50-50 is just fine for redoing it as well. From testing as well, I've done a lot of graphics cards now with it, so I'll be just fine. And then we're going to grab this board and get it set up. Yeah, I got this board and get it set up so I can grab a MOSFET. Which is a 4921N. 4921N. Now, the trick I wanted to show you for being able to see and say, yeah, it's a lot of cat here. For being able to check the MOSFETs easier if you can't read them, if it's not like a silk screening or really good etching, grab a little bit of thermal paste. Just go rub that all over these. It's gonna be one of these ones anyways, but rub it all over like so. Rub it in really good. Then you gotta grab a new Q-tip. And what we're gonna do is just wipe it away. Like so. And now, look how easily you can read that. Focus you. Look how easily you can read that. It's a 4927N. I need a 4921N. Hmm. Well, it should still work, technically. Yeah, this card here has one high side, one low side, two high sides, for some reason. No, this is a GTX 770. Yeah, there's an empty slot. Yeah. This card here has a lot of issues with this controller. One MOSFET blowing up, but I'll buy a bunch later on in the future. I'll buy a bunch of GTX 770s of this model, and what I'll do, broken ones, like guarantee broken, either the core or something, and I'll just grab this actual, so this is a resistor divider for this card here, that's all on this chip. I'll just replace the whole chip and replace the one MOSFET, not a big deal. Plus it's missing a cap here too that got shorted out. I just ripped it, well, desoldered it. Good enough though, good enough. Give me a sec here. Clean this board up quick. No, 770 is more powerful than a 760. No, the empty 8 pin is a location in which they could have added in another 8 pin on the side, or it could not be even hooked up to something. So what I would have to do is check each of these pins here. So here, show you here. So for the way these graphics cards work, you'll have your 12-volt source on the bottom. Depends on the way they're laid out. Depends on where they're laid out here. But this one here, because of the way it's laid out, is you got your grounds at the top, but one of them will also be a sense pin. So you'll have grounds and sense pin. For the bottom side, for the other side, so the inside, like the bottom here, so here's the top side, so this is the top side, that's here. You'll have sense pin and grounds, or it's basically, right here is your sense pin, grounds. So sense pin, ground, ground, ground. For the bottom, you'll have also your 12-volt source and a sense pin. Some people call it a data, but it's a sense pin. So I would have to check to make sure that it's actually running to components and not actually running to anything bad. So you have to check to make sure if you want to add in another 8 pin, since this is an 8 pin plus a 6 pin. If you want to add in another 8 pin, you'd have to check to make sure it's actually ran to something, or if you hook it up, it could be literally to nothing, or it's hooked up to internally somewhere, and you can literally fry the board. Just because it's here does not mean you populate it, though. You cannot, like some board manufacturers, that it's just here. Oh yeah, it's here, but they'll use this PCB on a whole bunch of different models. Same exact PCB, completely different configuration though. Configuration as in capacitors, your MOSFETs, your chokes, like the actual layout. See how this one's missing caps here? It's missing caps. It's missing more caps over here. Some of them will be missing actual like controllers, like right here. So this controller here is for this phase. This controller here is part of the switching frequency that also talks to the chip here for switching frequency. So you can change resistor divider on this here that changes the switching frequency here that talks to this controller here. If this controller here can't go as high of a switching frequency as this PWM controller here, and this you modify this to run a higher frequency that's past this controller will blow up. So, and then some cards won't even have these switching frequencies, generally if it doesn't have an actual spot for the actual card, like another VRM, another phase for it. Since this one's 1 2 3 4 5 plus 1, so it's 5 phase card plus 1 for the memory. Hopefully I am not going too fast for you on that. But yeah, you can't just throw in another 8-pin if it's just there. It could be completely different layout than what the card supports. And I would have to do a bunch of multimeter testing. Yeah, and I have, so that 1 6-pin that you have could be run into a whole bunch of phases, and then your card's, let's say, missing some phases. So it's missing. So let's say these are your chokes, and then you got more MOSFETs over here, but they're not populated. And then also you can notice that your controller is not populated. The capacitors are not populated. There sometimes is like a little resistor that's not populated there as well. And then you also see that you have another 6-pin or 8-pin. That could be for a higher end model that is going to run a larger VRM or have more phases in that VRM. So if you hook that up, it's literally going to do nothing. It'll do nothing, or the voltage that's going into all of that is going to hit that and then literally fry the board. That's why you would have to add in switching frequency controller. You would have to add in all the caps. You have to add in your MOSFET, so whether it has high side, one high side, two low side, or two high side, or two low side, one high side, and the exact same choke is what's running on your VRM. Yep, and that's the thing, because they'll have the exact same PCB as, well, some cards will have the exact same PCB from the 7850 to a 7950. Exact same PCB, completely different layout though. So I need the 4935N. Oh no, wait, I need the 4927N. And we're gonna put that in place. Actually, I'm gonna search the data sheet for it. 4937N MOSFET. 30 volts, 70 amp. Holy. Now, what is drain? So source, ground. I don't want 493. I want 492. 492. Yeah, 4927N. 4927N. It's a 30 volt, 38 amp. 7.3 mega ohm at 10 volt. It's source, ground. Drains are on the side. Four, 9, 2, 1. Source, ground. 6.95 at 10 volt. And it's a 58 amp. That's also saying high side. Oh, it's a high side. Oh, yeah. Two low side, one high side. Correct. I was looking at the wrong spot, apparently. Yes. So the other one is 4927N MOSFET. It's only 38 amp. It's only 38 amp. What about 493? What about 4935? Ooh. Only 16 amp, 5.1 mega ohm at 10 volt. Dang. Sixteen. 4921. Yeah, 4921. And then 4927. 4927. Should work. It's just only 38 amp. And that's going to do the 4921N. 4921N, which is 58 amp. It's basically the same mega ohms at 10 volts, which is good. Which is good. Four, 9, 2, 1. It would technically work. It will run a bit hotter. It'll just run a bit hotter. So, as long as I can keep it cool, it'll be fine. It'll be fine, he says. Yeah. 2080 Ti will outbeat the 6800 XT. They're basically on par with ray tracing. Raw output, 2080 Ti has more raw output. Gate to source voltage. Gate to source voltage. Same. Continuous drain current. Continuous drain current. Power dissipation, 2.7. Continuous drain current, 58, 38. Maybe this one won't work. So, what I'm going to check. Decisions. It's continuous drainage is not appropriate, which means it can run very hot. Yo, how's it going there, honey and guh? How's it going? So I need the 4927N. 4927N. Yeah. 38 amp though versus 58. It's gonna run warm. Everything else looks like it'll be just fine for it, but should work. Should work. It should work. All right. Oh, so we are gonna warm up this board. We want this guy right here. It's gonna preheat the board. Sip on my coffee. Good, good. Ah, fridge are replaceable. Hopefully you got one cheap though. Did it put in a bunch of years before it went though? Also, do you know what happened to the fridge? Oh yeah, it paid for itself, man. It definitely paid for itself. Yeah, yeah. Motor or compressor, you mean? There we go. MOSFET. And then what I'm going to do with this MOSFET is simply, I said simply, there we go. This, clean it up with some new solder on all these, perfect. And I'm going to clean it up. Oh yeah, yep. Yeah, as soon as you heard it go loud, that's when it was going, I am getting very hot. Sir, I'm getting very hot. Sir. Sir. I don't want no more. Ah! There we go. Hey, we're gonna preheat this board here. Preheat the backside a bit. I want something for the capacitor here. And shouldn't get too hot. And well, that's how easy it is to replace a MOSFET. So that's all done. There, I'm just gonna clean up some of the flux I had on the board fixing stuff up before. Well, more or less taking off the MOSFET, other components. That's it. There's the new MOSFET. It's gonna run hot, but it'll do. Now, because I got it all set up, just give me 1 sec. Just want to make sure just want to clean it all up nice and pretty here. I guess we're to check it with the multimeter here. It would have worked before without the MOSFET, due to the fact it's doubled up high side. Yeah, I already had this board working. I had it working without the cap, without the choke, a bunch of other stuff I'm going to be replacing here in a second, and without the MOSFET. I already had it working and testing, and it undervolts like a madman. Again, it's still got the switching frequency and all the mods onto it as well. I don't have the voltage control for the core set up onto it right now, just because it won't run on the stock cooler with more voltage, so we're just going to leave that be for now. But it has switching frequency, no overcurrent protection, voltage control, memory control voltage as well. Extra capacitors, of course. There we go. There it be. There it be, right there. There's our new MOSFET, 927N. It's that easy. So what we're going to do, put back on there. 9,920 kilohertz. Yeah, 920 kilohertz. 920,000 times a second. Yeah, from the stock 270 kilohertz switching frequency to 920. Yes, still at 920, and it still runs just fine. Here. Oh, I didn't. Hold on. Hold on. Give me a second here. We'll just. Boop. Of course, everything's in my way, but we're showing. So, ground, gate, perfect, no short. Ground, gate on the other MOSFET, perfect, no short. Ground to source, which is ground. Oh yeah, my multimeter's gonna be. Don't do this to me again. Give me a sec. It likes to do this sometimes. Not sure if it's just my way I have the wires right now and all that. Yeah, come on. Work yourself out. Might have to use new wires and get them set up. Still showing too high. Let's move this out of the way. There we go. So choke. Come on. What are you doing to me? Gate. Perfect. Gate. Perfect. Source. Source. Should be reading a bit lower, but if I hold it there long enough, it will. But there's no shorts. There's 0 shorts. Here. Gate. The 0.3 and all. The 0.3 is perfect. 0.4. Gate. Perfect. Back to the gate on the new one. Perfect. Toke. Should be reading like as low ohms as possible. Not sure why when I have the multimeter set up like that, it doesn't like it apparently. Let's move that. This is how you test them. If I hold it long enough, it'll go down to 0.1, which is really good for a cheap multimeter. Like, this is really good. The 0.3, like, almost instantly, almost 0.3, it's really good. Really good. Gate. Source. Source. There's a little bit of flux still on it. Figure yourself out. Come on. It's just because of the flux on it. Perfect. I need to get isopropyl still. Perfect. New one. Gate. Perfect. Source. If I can get it to stop doing that. Hmm. Hmm. Let's go a bit closer to it with a different ground. Still reading kind of high. Still low ohm, but still reading quite high for some reason. Gate's reading perfect, as in 47 there. This gate here. Nice. This gate here, which is fine. More about the comp. PC has to be approved for build under 150 USD. And all done on Discord? Under 150 USD? Technically, mine is. Technically, because I bought my motherboard used broken. I fixed my motherboard. I bought it with the CPU for $60. This GPU you can buy for like $30 Canadian. PSU, super cheap. So technically, I'm okay with that. Alright, now I'm going to check the 12 volt pins to make sure they're fine too. So, ground, yes. 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 12 volt, yes. 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 And that will change due to the fact there's capacitors and everything else in this thing. Board's cooled down enough now where it should be reading more appropriate. So ground. And it will eventually. Oh. Oh, not on it. Ground. Sense pin. Ground. Ground. Sense pin. Ground. 12 volt. Yep. 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 Okay, everything's cooled down now. I want to check this over again. Let's try to clean this up. Maybe I'll hit it with the soldering iron quickly here. Tip might be a little big. That's what she said. Just to try to clean some of that flux. $47 kilo ohms is a little high. It should technically work. Just for some reason that's also reading pretty high. I'm not sure why. Oh, give me one sec here. Let me just. I don't have a perfect test bench set up right now. That's something that will work. Okay, so there's no pop bangs. I'm just gonna test it with the multimeter quick. I don't have everything set up properly for showing you. Just give me a second. Yep. Okay. All right. So perfect. So card does run properly. Loads up 900 millivolts is what it loads up as for enable, and then it will go down in millivoltage will go down to about 820, 830ish, right around there, for when it loads more of the BIOS. So perfect. Everything's good on that. Too powerful? Man, they're fucking just retarded on that. You're joking. Too powerful. But they got it set, like, did they change the way things were on it for the rules? They did, didn't they? Like they changed it all up. They must have. Oh, poverty rigs. Oh. Uh, uh, 240 CUDA cores or fewer. Sure, what GTX 460 have? 336 CUDA cores, of course. So I will have to use my 9500 GS. All right, now I guess I'll be using my GTS or 9500 GS modified one. So I will not be using this GTX 460. It is ready for more benchmarking though. Well, that kind of sucks, but we got it ready for more benchmarking. Oh man. Okay, well, I'm gonna add some caps to this now. Instead of these 10. Yep. It has 334 CUDA cores, I believe, right? 336 CUDA cores is what it has. So, yeah, 460 is too much. It's fine. I'll just use the 9500 GS. Not a big deal there. Oh, give me a sec here. I'll zoom in. Yeah. Now, where did I put them? They are. There, and there. Oh, yeah, there. Then we got these little guys, which are 22 microfarad MLCC ceramic capacitors. And we're gonna we'll use some hot air here. Yeah, I mean, not a big deal for me. Not a big deal. Wait. Go. Those caps are back on. Getting solid. Yeah, but so did they say anything about like is it supposed to be 150 USD dollar at time of the hardware? Because that's impossible to build a computer, a $150 computer back then, or like what you could buy now with 150 USD. So like 177 ish Canadian, 180. Oh, $203. Okay, yeah, mine definitely that cheap. It's eBay value. Okay. Oh, that's not fair either, though. Well, I mean, I can show proof of purchase. I bought mine for $60 because I fixed mine up. So I mean, like that. How does that work? I bought it used, broken. I brought mine for I brought mine for parts. So how does that work? And it's in the Discord too. I'll never join that Discord channel again. Fuck those retards in that channel. Holy fucking shit. The mods are retarded. There's just retarded people in that fucking channel to begin with. Like, actually dropped on their fucking head as a child. I even said that. Apparently one of the mods didn't like that. You could just put it in, yeah, the Hot Robot channel. Yeah, oh my god, there's just retards in that channel. Like, actual, like, people that have one submission done, nothing to prove of their knowledge of what like some people's questions are, and they're trying to tell them it's like the answers for it that are completely wrong, destroy your kind of hardware wrong, and then the top overclockers in the world and me are saying, well, if you no, that's not right. You use that too much voltage there. You can destroy your hardware no matter what. Basically, like top overclockers in the fucking world are saying the same thing as me, and yet there's people in there has one submission, nothing to verify anything of sorts of even the hardware that they're saying, and like ganging up on people that are giving proper information. Oh yeah, yeah, yeah. And then and then you say certain things, the mods don't like it apparently, even though those people were saying worse things and not getting muted. Like fuck that, man. No wonder DeBauer is getting out of HardwareBot as a CAO. No wonder. Yeah, that'd be cool. Yeah, yeah, yeah. The single-eyed kings. Also, how's it going there, Cosmic? Yeah, it's just nah. Like the people that were given, like people that give wrong information, like those people in the hardware bot there. Like again, the ones that literally have no verification, one submission done, or a bunch of them that have two submissions done. Ooh, two submissions. Giving people with hardware of value when their submission is on hardware that's worth $1, and not even good submission, like an average, maybe top 200 type score on that bench for that hardware, like not even a good score. Trying to get proper information for voltages for stuff. No, it won't destroy your RAM if you run it at 2.4 volts. It'll handle it like a champ. It'll be just fine. Ambient 2.4 volts? No RAM IC will handle 2.4 volts. I don't care that you're saying it's Samsung that will handle 2.4 volts. The IC will die and or destroy the PCB, which means you're destroying the fucking RAM. There's no verification done. Actually, well, there's a little bit of verification done actually back in the day for voltages and that, but they even say going past 1.9 volts does not matter. IC will damage your fucking shit. No, even DDR2. Even DDR2. 2.4 volts is too much. Will start, it will like real time degrade it, man. Yeah, it will real time degrade even DDR2. You would expect it not to. DDR, of course, it's 2.4 volts for DDR is fine, but that's a different story. Yeah, they're trying to say Samsung's fine for 2.4 volts and not degrade your RAM. That's weird. They've made RAM kits back in the day for DDR3. Um, they were, I think some of them did 2 volt, but a lot of them were like 1.9. But some of them, I think there was a couple that did 2 volt. And there are literally a handful of those sticks left around due to the fact that it was too much voltage and it degraded it quickly. Now, 2.4 volts at ambient temperature is going to degrade it in real time. And then yet the morons are trying to say, no, it's fine. And then you ask, and I ask the actual, some top 20 overclockers, and they go, yeah, that's a lot of voltage. It will degrade it. It's like, well, thank you. I already knew this. I just need more clarification from actual benchers, people that actually do this kind of stuff, not from people that are put in one submission. Good job, that one submission guy. Good job. You do not qualify to give information to anybody besides yourself. Have you? What? I mean, what exactly are you looking for? Kingston made a lot of decent RAM. Do I want to add these extra caps? I don't think I really need those ones. I do. I'm glad I got these 22 microfarad on there though, because there's only 10 microfarad, so maybe this will help. Probably not much. The main thing for adding on capacitors is around the core, and maybe a couple extra like tantalum polymer caps here that I got that added on. Those right there would probably be more beneficial than anything else. From what I remember, I gotta add, that's basically it. So new MOSFETs on there. New MOSFET for anybody that's just joining. There's the new MOSFET. Already tested, works. New caps. Better caps than what was on there originally. I bet those IDE to SD would be not half bad. For like DDR4 to DDR5 or DDR5 to DDR4, you're literally wasting your money buying those. For anyone wondering, you're literally wasting your money. Oop, a little far there. There we go. Oh, maybe I will add those on there. Why not? Why not? So, got that replaced. I should check. I forgot what the feedback pin is. And to one of those resistors, I gotta add the voltage control to. Oh, wait, no, I didn't put this to feedback. I put this to voltage sense. So, I gotta figure out what was the voltage sense again. I'll do that later on. He's talking about RAM. Cosmic. Oh, wait, ID. Oh, sorry, my apologies. No, he's not. I need the SD card. IDE to SD card. What? How? And IDE to SATA, I mean, that kind of makes sense. But IDE to SD card. How? Yeah, it would be cheap. But how did they make that work? How? Because SD, ID, like, they'd have to down the voltage. Yeah, it'll probably be pretty good to do there, Cosmic. Yo, how's it going there, Jason? Yeah, it'd be probably pretty good to do SD to IDE. Yeah, not much slower. That's not much slower. How's it going? Alright, we're gonna add some caps. Alright, we're gonna add some caps. So, what we're gonna do is. Hey, oh, yep. There we go. There we go. Ooh, loud. We'll put this to resistance. And we're gonna make sure, because I don't want to flip over the board. I'm just showing you here. I don't want to flip over the board. So we got. These wires do not like to be in a certain location on this. There we go. A bit better. So this side's ground. So this is ground. This is positive. Ground. 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 A little bit of flux on it. Not reading it. Ground. A little flux on it. Not reading it. Ground. Ground. So if we flip it over and show you all the ones to me, as you can see, The caps are facing me. So that'll be your ground side. The side that's not marked on these caps here are positive. So all the ones facing that way are positive. All the markings here, whether it be red or blue, will be your ground. Tandem polymers. So you surface mount tandem polymers. Your ground will not have that mark. And all these are actually kind of nice the way they did the grounding to it was. So if I just put this to this end here, as you can see, that's ground. Now we have this little line. So let's see this line. That's our plus on tantalum polymers for surface mount capacitors. Your marking right here is your positive. Okay. And it's nice how they did it on this board. Ground, big ground. It's right there, right beside the ground, so they face them that way. Same thing with here. Ground, positive. See, there's a positive plus sign, but there's no plus sign on this one, right? So something. And then your ceramic MLCC caps, they're universal. Okay, they're universal. So all ground to me, which means I'll be putting the caps like this to me, marking to me. You put them the other way, you'll blow up the card. It might work for a little bit, but it'll blow up the card. What's wrong with the graphics card? So this card's been extremely modified. It's got basically every single modification you can do this card. Voltage control, no overcurrent protection, over voltage protection. It has switching frequency protection, more capacitors put onto it. But doing some testing and whatnot, after switching frequency, I blew up a MOSFET. So this guy right here, I blew up a MOSFET. I just replaced it on this stream. It's not as good of a MOSFET, but it'll work. It'll just run a little bit hotter. That's all. Seven different screws. What? Oh, yeah. That's nothing. 7 different screws is nothing for some electronics, man. Nothing. What I'm going to do is just preheat the board. And yeah, it's good to preheat the whole board, even though you gotta work in one area. A lot of copper and graphics cards that soak up and transfer heat, so. Exactly, yeah, heat more. So your grounding, I can show you the planes. I can show you the planes. And see how we have different coloring, right? So you can see the traces and all that, and the cat hair and everything else. Can't even get rid of it. But yeah, you see all these planes here, like this one here, this one here. See how these planes go near. Oh, well, it's really hard to show. Over to here. Some of it will go into it, some of it won't. Some will go over to these pads and traces, and another grounding plane here. So extra capacitors for more decoupling filtering. Yeah, decoupling filtering, and then for actual filtering for, yeah, the card's repaired. This card's just been heavily modified for going after some records. But yeah, so you see all these planes here, right? Now, if you want, what I'm gonna do is grab another card, because I don't really want to scratch this one up. I mean, it's not really a big deal, but I don't want to. Okay, so we got this card here. All right, it's a little dusty, but same thing. So as you can see, we see these planes. So yeah, one plane here. Where does it go to? Like, what else is there, right? So what could this plane be used for? Right? And then even though the plane's going through this cap, which one side of the caps could be your ground, one side could be for power, even though that power could be on a different layer than this plane. And this plane's very close to the surface. So what I'll show you is what we're going to do. So here, this plane here, as you can see, make sure I show. Don't mind the more cat hairs. Has also just been sitting wildly, but yeah. So as you can see, we got this plane here. We got this here. We got this plane here. Traces everywhere. Which are, as you can see, like all the traces here. You can feel them too if you really wanted to feel them. But what I'll show you, let's put this to ohms. Now, your screw holes will always be a grounding. So if I put this probe here and this probe here, this will read very low ohms. Unless I got a short somewhere. Unless I got a short somewhere, or a multimeter is not liking the positioning of those. There we go. So here and here, very low ohms. It'll keep going down eventually to like 0.6, or if I hold it long enough, it'll go all the way down to 0.1, which means that this point and this point of this are connected technically, okay? So it's basically like putting these two probes together. All right? So if I scratch this layer, to expose the copper, if we hold this to here, if I can get it to get a good point. And it should go down. I'll scratch it with this thing because it'll be easier. There we go. And to one of these. There you go. It's a ground plane, and that's just by, and you do this for modifying too, to testing the ground planes on. Let's say you want a good ground spot. What you'll do is you'll grind away the layer, which is just a epoxy plastic. Okay, that's all it is. It's just a plastic epoxy that's good for high temp. And you're going to scratch away this layer to expose a big ground, as in the better you're grounding for like doing a lot of hardware and stuff like that, the bigger the grounding that you can do for whatever you might be doing. Let's say you're adding an extra voltage or something like that. So like this card. So like this card where I added an extra power because it doesn't have its own. So I added its own 6-pin power plug, which is just a 12-volt source, which your 12-volt source will also come from here, down here. Right? Wow, technically here, down here is there, okay? So what you're going to do is have a nice ground plane, nice big ground plane, which wherever you got these connections, so like this DVI port here or VGA and that, these are just ground points. These are just secure points to hold this in place very strongly. So this is a really good ground plane. So for good grounding, that's what you want for something like this. Just a really good grounding. And let's say you want to just put it somewhere else on the board, you can scratch away a layer of the PCB, epoxy layer of it, expose it, solder wire right to the PCB somewhere. Done. Like a so. Yep, that's what ground plane. And some layers will. Well, generally it's usually more internal for power, but yeah. And I'm just adding more capacitors so that way load is consistent. So as soon as the load hits the graphics card here, the load that's put charged into these caps can be drained into the core faster than what it would be from the actual power supply or your 12-volt source. And decoupling. It's decoupling filter. The better filters are going to be your smaller capacitors always. Your surface mount is going to be better than your can caps no matter what. The smaller, the lesser of the microfarad or lesser of the actual caps, these smaller caps. So even these 0608s, I believe they are. I believe these are also, yeah, I'm pretty sure these are 0608s. The 22 microfarad caps would be better for higher switching frequency than the 47 microfarad caps. Or even a 10 microfarad cap will technically be better than the 22 microfarad cap. Depends on how you want to do it. These are all 47 microfarad caps on here, every single one. So it's basically like an extra $50 just in caps that's on this board. More more money in caps and hardware than what the board's actually worth. So we'll just continue adding on some caps. Oh, I gotta preheat the board again. If you're wondering why I'm heating up over here again, for anybody that just joined, it's because the board will move a lot of the heat around due to the fact all the copper layers and copper grounding is in it. So I just want to make it so I can solder more onto it without preheating it again. I need some soda. Soda. I didn't put much on it. Oh, give me some soda. Thank you. Oh, yeah. Oh, yeah. Okay, there's another cap. This cap. This cap I've already taken off. I've already taken these caps off of this for going through possible issues that might be on this board. So I'm just going to re-add them, but I gotta clean up the solder on them. So best way is just add a tiny amount of flux to it and hit it with the soldering iron. Pretty easy. And I already put a little bit of solder onto these as well, to these contact points, the terminals that are going through. I've already done it. I'm trying to set this up nicely, please. There we go. And I need a little bit of heat. I've already, yeah, it's already sucked away all the heat. So I'm just checking, make sure not a lot of heat's hitting the capacitors. Go. Give me enough solder for this. Thank you. And we'll get a little bit of flux on there just to clean those up. There we go. So that's 3. I'm going to add another 3 onto that. Also, when you're doing like LN2 or going really cold, dry ice is not really that much of an issue, but LN2 for sure, especially liquid helium. It's even colder in LN2, but for LN2, you have to basically add capacitors. Either MLCC, like a ton of MLCCs, basically every single spot you can, memory, and for also the core, mainly the core, because the core is going to get very, 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 very cold. As the temperature goes down on a capacitor, either a aluminum polymer or even ceramic capacitor, or even your tantalum polymers, they will actually lose capacitance, as in below negative, it's generally below negative 50, it starts going down very quickly the colder you go. So you can get the core down to full pot negative 190, which the core will probably be around negative 180, 170, depending on how much voltage, wattage going through at the time. But it's around negative 160-ish, 170, right around there. You're losing over half the capacitance of a capacitor. Over half of it. So you need to add more capacitors. No ifs, ands, or buts. He said buts. Now, is this warm enough? Hey, clean it. Is it gonna be warm enough for me to... Hey, it was nice. Yeah, that's what I want. Maybe it's solid. Now what I did was angled this one so that way the edge of it's hitting the board. And then this one's just leaning on that, so that way whenever I lean this part over, it's not going to wiggle the capacitor at all and or weaken the joint, the solder joint. Oh, probably. Probably. And that's why I'm using 9500 GS now, all of a sudden. I thought the GTX 460 would have been fine, but I'm not doing it for the competition anymore. Yeah, but I mean the way the points get ruled, it's more or less just for fun, man. It's for fun, god damn it. So we're gonna have fun, for fuck's sakes, god damn it, it's for fun. Fuck. Kill another cat. What happened to my other cat? What happened to my other capacitor? God damn it! Oh no! I have to grab another capacitor. Apparently, I have to grab another capacitor because I don't know what happened to my other capacitor. Give me 1 sec. Oh wait. Oh wait. I think I should. Oh, right here. Oh, I have a box. I have a box of capacitors. I don't have one of the same one that I want to use. No, it's a 2.5. That's 2.5. That's 2.5. Those are all 2.5. Why not have another 16 volt? And those 2.5s are good. These are high-end 2.5s. They are Ninja, or no, they're Panasonic, which are really good. And I don't want. God damn it. They're all 2.5. 116 volts. I want them to run nice and cool. God. Well, we got these. More caps. We got caps. Yeah, lots of them. Not a big deal. Hey, that's perfect. It's a perfect length. And we got pre-tenom. Perfect. Now, ooh, maybe that a little long. I mean, they're short enough, but we'll shorten them a bit more. There we go. Shorter. Make sure they're tinned up good. There we go. There we go. Board's not board's not warm at all, but that's okay. No, it's not okay. We'll just get it attached and then clean it up. There we go. And then we just need a little bit of flux to clean this up. Get rid of these horns off of it. There we go. Clean these up a bit too, since I'm here. Come on. I have to. Oh, no. Just had to hold that into it a bit longer than what I wanted. But yeah, we got lots of caps now again. Woohoo, let's go. Lots of decoupling caps now. There we go. And this card's ready for benching again. Ready for benching. Now, I wonder how long this new MOSFET's gonna last. The only thing that's really wrong about it is it's a little bit less amperage than the originals. Same voltage, 30 volt, but less amperage. About almost 20 amps difference. I don't think I'm gonna stress them out that much, to be honest, and I'm pretty sure I'm gonna keep them nice and cool. What I would like to do is make some nice VRM. Wow. VRM is your, again, MOSFETs, chokes, and capacitor generally is what makes up your VRM. Phase, VRM, per phase, three phase, one phase for memory. But yeah, I would like to make up some MOSFETs, something to cool the MOSFETs, something to cool the chokes, like just a single little, I don't know, copper. I would like copper. Nice little copper heat sink on each of the chokes. Same thing with the capacitors here. Add some capacitors to it, or some heat sinks to these caps. Not like it's really needed, but having it on these three main. I don't think I have to worry about this choke for the RAM. The RAM won't get that hot. Like, it's not gonna be stressed out like anything else really. But yeah, I need to make something for the MOSFETs to keep them nice and cool. Oop. Oh, budget restricted benching competition. Oh, Natty Cathy's doing it. Natty, I didn't know it was done by Watson80 and Natty 2K or Natty Cathy. Natty Cathy is, I'm pretty sure, Trash Bench, is it not? Because I thought Natty Cathy was Trash Bench. Yeah, good and solid. Bam. Yeah, it's good to go. Pretty sure that's all I had to add back on to this card. I'll add it on better. Caps there. New MOSFET. Didn't have to add any caps on this side. No. So I think that'll do. That'll do, donkey, that'll do. I'm pretty sure Natty Cathy is, because I talked to him, and he's actually chill as fuck. Chill as fuck. Natty Cathy is chill as fuck. But yeah, I was talking to him, and he's like, well, I am a trash bencher. I'm thinking, sounds like trash bench. Like, and the way he talks, like chill, just like trash bench in his videos, even though I'm reading over through messaging, it's like, man, and he kind of has the same hardware as him. So, and he does use chillers. Pretty sure Natty Cathy is Trash Bench. Ta-da! Ta-da! Where's Vep? Where's Vep? Ta-da! Oh. Burt Wonderstone. Ta-da! It's so good. So good, man. That's such a good movie. That's a different dog. What'd you do with it? He put the dead dog in the magician's fucking pants. Oh my! And probably not many people got that. That was fucking good. Yeah, I don't. There's nothing that I can think of that would help this card. I mean, I could add more caps to the core. I got caps for the memory controller, caps for the core itself onto it, caps on, of course, the memory chips. Lots of extra caps from each memory chip, but I could add on some some 0402s, some tiny fuckers. Oh wait, these aren't 0608s. These are. Oh man, they're big. These are a lot bigger than 0608s. These are 0402s. The next size up is 0608, and then it's. Oh my god, think. Brain, where are you today? God damn it. Oh, sir. Yeah, guess I need to add a cap there too. I mean, it's not really needed. Not really needed. So just give me a second here. But I am going to end the stream. So we are done. We're done, and there's not many viewers. So we're going to end the stream. Yeah, yeah. Nah, it's definitely can't. Well, maybe it is one of the shortest streams. 2 hour, just over 2 hours. Basically, yeah. It's a short one. It is what it is. Yep, that is it for this one here. Cards all fixed up, ready for more benchmarking. It's all that matters. Was gonna make a video, but figured I'd do a live stream. So, thank you all for watching. Not yet. Stop. Yeah, read over it again. Probably not gonna participate. I'll just build a piece. Well, maybe I'll. I still gotta build that test bench that I wanted to build. No, not today. I have the camera set up for this. Actually, give me 1 sec. Maybe I can quickly set it up. Gabby! Come on. I'm waiting. Oh, I don't want to pick you up. God dang. You're so needy. Why can't you just jump up sometimes? Come here. Well, come here. There we go. We got the nugget. We got the nugget. We got the nugget. Oh, you want to lay down? Oh, you do. Oh, you guys smell the graphics card. I see. Curious kitty. Curious kitty. But there's a nugget. And I'm in the stream. Again, thank you all for watching. I should be on tomorrow at some point. Might do an early one. We'll see. Who? Who doing the Intel Pentium 4? Who's doing the Intel Pentium 524? Oh. Intel Pentium 4 524, yep. So we got CPU frequency, Symbionic 2003, Pi Fast, Super Pi, 32M, and W Prime 32M. Sparks is in first. 6.8, almost 6.9 gigahertz on it. Holy shit, man. Oh, holy shit. Dude, that's wild. That's actually wild. I don't want to know how much volt he's using. He's probably close to 3 volts. I would assume close to 3 volts. He's over 2 volts, guaranteed. Yeah, even the almost 6.8 from tag. Holy fuck. That's flying. On a Pentium 4 524. Holy shit. Even Leghoff did 6.5. They're on Ellen too, but I don't care. Like, that's wild. Getting close to 7 gigahertz on it is nuts. Tomac also did it. Holy crap. He is wild. And he did LN2 on the RAM too. Cast latency 4, TRCD 4, TRP 4, and TRAS of 12. Gotta love DDR2. No, wow. 6.5, almost 6.6, 1.864 volts. So not even 2, well, Sparks is probably around 2 volts. Tomac, though, actually, what is Bastion? It says have voltage. Yeah, they're like 1.9 volts being shown. The ones that are higher frequency, no voltage, due to the fact it was probably so cold the voltage wasn't showing, as in a cold bug for it, or they disabled monitoring for voltage. Yeah, probably disabling monitoring for voltage, I would assume. Did you see? Did you? I gotta show this. This is awesome. Oh my god. Oh my god, dude. Oh my god. Holy shit. I don't think you've seen this though. Transform. Oh my god. So this is need more beer 88's Pentium 4 sub. Yeah. And just a cheap ass fucking LN2 pot. Nice. Corsair magnetic levitating fan. But yeah, look at that. Yeah. Look at all the beer. That's awesome. That's awesome. They got a little GPU off to the side here too. Need more beer. Let's look at those fucking high as hell. Got a buzz. Old man's got a buzz. He's got a buzz. He's high as hell. Got a buzz. He's still working on it. That's awesome. That must have been a very long session. But the comment they put onto it. Beer okay, score also okay, I guess. And then Shaggy, this session. Yeah, this session. Yep, they were they were having some fun. Just relaxing. Look at all these old GPUs that they got up there too. Yeah, a whole bunch of GPUs. Yep. That was one hell of a session. That's awesome. Yeah, voltages for top ones can't see the voltage. They're around 2 volts, at least 2 volts. Tomac is almost 1.9. At least it's showing. Oops. It's showing the voltage, but it's not probably the correct voltage. This probably is not the correct voltage. To get one of these CPUs up there, it's a lot of volts, real cold. Oh, look at all these LN2s. Just a random what? Is that phase change in the back? Yeah. Some Star Wars. That's flying though, man. Almost 6.9. If it was 6.9, nice. That's so close. It's wild. Yeah, more than Golden CPU. Yeah, with effort, I expect to do 6.9. Yeah. Yeah, I don't think the VRM is holding it back. What board did he use? Yeah, he used Striker 2 Extreme. Plenty VRM for it. Close to the motherboard that I had for this chipset. Pretty close. Mine was technically a downgrade from it, but basically exact same motherboard. VRM is fine. I don't know if you'd be able to increase switching frequency. That would maybe help. Like it would maybe help. That's crazy. That's crazy good. Very like insane score. What? A grinder? I don't have a grinder. What? Yeah, no, crazy. Crazy good score. Oh, that's not what I wanted. I want to see the other. Oh yeah, this is the page I want. 711 and some bench score. That's some bench 2003 though, by the way. Pi fast 33 seconds. Like, dude, he probably has first in all these then. Yeah, first. Second. so he's not able to get his RAM. More beer equals more better. I definitely needed more beer to make a great score here, but more on 2 would have helped. I was running on vapor. What is his RAM at? Oh, no, his RAM 666. Oh, maybe he couldn't get the RAM cold enough to go lower. Yeah, because 666 24. This is not EA. The RAM sticks are not the greatest, or wasn't able to get cold enough. Because you should have been able to do like 444, 12, 22. And third in W prime. Yeah, same. Still not able to get this latency down far enough for it. I mean, still good. Still crazy good. Still good. Very nice. Yeah, crazy. 3-way SLI. Yeah. Because no one, like, they didn't really do, like, they haven't pushed the Titans that hard. Even the 1080 Ti's. Like, they got some records out there that still haven't been beaten, but they can be beaten. Especially with the hardware we have nowadays. They can be beaten. DDR3. Or 2. It's DDR2. Oh, no, yeah. No, he does have a DDR3 board. My apologies. No, your board would have been using DDR2, not DDR1. It's either 2 or 3, depending on platform, like motherboard platform. Not all of them supported DDR3. So if we go... So actually, that's not bad. He was just not able to get certain timings down far enough. If we go... Is it Tomac? Yeah, DDR2 for Tomac. I should have known that he was on also DDR3 as well. Because again, this board, I had just a slightly lower tier, basically exact same board, but lower tier board than this was DDR3 for this platform. So I should have known it was DDR3. And looking at these dominators. That's still really good though. It's just that's a lot of beer. Sitting up on top of beer surrounding. It's just wild. Very nice. And need more beer. So I'm just wondering how he's able to use the same subs. Right? That doesn't make sense to me. Rampage, Formula. Different boards. Okay, yeah, so they ran with their own hardware onto it. Probably same CPU, but same different hardware. Might even be different different CPU as well. Not all of them. Not all of the X38 and X48s will support it. I mean, changing the pins around, yeah, for changing frequency. Different platform though. Different motherboard platform. How many generations did this go through? 7? No, 5. 5 or 7? There's 5 or 7 generations it survived of platforms, but not fully on each platform. Not fully. Not every single motherboard made in a newer generation platform supported it. As in going to DDR2 and 3. Generally, it's more or less DDR3 though. Not all of them supported it. It survived a lot of platforms. It's pretty wild. Alright. Put away the solder. Put away my pound of solder. We done with that. Oh, now I can't wait to test this graphics card out for hopefully end of this year. I'll be able to get a bunch of stuff set up to do actual chilled runs on graphics cards, because last year and this year I was not able to, because I didn't have any liquids at all to be able to handle chilled. So I'm hoping to be able to do chilled end of this year, or maybe sometime this year I'll be building the chiller and we'll do it then. We will see. We will see. Yeah, it's just crazy, crazy good. Speaking of cooling, he says. Yep, air cooling only. That's why I was gonna modify the actual cooler a bit, but there's no point. There's no point. Because this air cooler sucks. It actually sucks. And because of the switching frequency, it runs a bit hotter. So it runs hot. She runs hot. Yeah. Doesn't matter. I'm not participating in it. I am not participating in it. I'm not joining the Discord channel again. I'll just get myself banned. Because I can't hold my tongue to retards on there. If you're dropped on your head too many times, you should get yourself checked out, and yeah. You got it. You got it. Not dealing with it. What do you want? Yup. But yeah, I should end the stream here now. Should end the stream. Relax for a bit. What do you want? Next card I'm gonna repair is the 8600 GS as well. I gotta get it to give full voltage so that way it'll it activates the enable pin. I think it's around 700 millivolts it needs, or at least 600. I could be wrong. It needs 800, but I think it's 600. It's only doing 360-ish millivolts. It's not enough to enable it. So I gotta figure out how I can get more voltage to pass through. You boot at 250 FSB. Holy. Yep. I'm gonna end the stream though. Again, thank you guys for watching. And yeah, I'll try to be on tomorrow at some point. What? Hi. Yeah, try to be on some time tomorrow. And yeah. Again, thank you all for watching. And that's it for this one. So, again, as always, don't forget to get her done. Peace.